Welcome back, learners. Today I'm going to introduce you to carbon and its compounds. Carbon and its compound. We have allotropes of carbon. The allotropes of carbon, when we talk of allotropes and allotropy, allotropy is the existence of an element in more than one form. Like when we talk of carbon, for example, in our case, we are talking existence of carbon in more than one state, which is graphite, diamond, and maybe the other one that we call fluorines. But for our case, we are going to talk of graphite and diamond. So if allotropy is the existence, it means the different forms of or the different forms which we are calling them graphite and diamond for carbon, they are what we call the allotropes. And we have two, diamond and graphite. For diamond, if you look at the structure of diamond, it is a rigid, and we talk of it uses the four valence electrons to form the covalent bonds. How? We know carbon has an electron configuration of 2, 4. For diamond, it uses these 4 valence electrons to form covalent bonds. And we'll see for the case of graphite because it is different. And therefore, if it uses these 4 electrons, automatically it means it has no delocalized electron, and therefore it does not contact electricity. Because it lacks the delocalized electron, since the 4 valence electrons have been used in forming the bond. Another thing you should know about diamond is about its density. And its density is high, almost 3.51 grams per centimeters cubic, and it is high due to the continuous close packing of the carbon atoms. And another thing you should think of is about the melting point. And the melting point of diamond is high compared to that of graphite. And this is due to strong covalent bonds. Remember about bonds, structure and bonding, where you talk of strong covalent bonds, where you talk of ionic bonds. So for our case, we are talking of strong covalent bonds. And there is another property, the last property about diamonds, about its hardness. It is naturally hard, and the hardness is due to uniformity of covalent bonds between atoms throughout the structure. So, and this property, it enables it be used as a most of the times like a drill and or a glass cutter. So that is all about diamond. When we talk of graphite, in fact it is another stable of allotrope of carbon, because we talked of graphite and diamond existence in different forms. It is slippery because it is made of hexagonal arrangement. As you can see, its arrangement, we have layers which are hexagonal. So we talk of graphite is made up of hexagonal arrangement, carbon atoms bonded together in layers, as I have said, and graphite has a low density compared to this of diamond. We talk of density being 2.3 grams per cubic centimeters. So, and this low density is due to the spaces between the layers. Remember, for diamond, it is closely packed. For graphite, it has layers. So the arrangement and the layers are bringing the point of it having low density. And we said it is slippery and soft because these layers or layers in the structure can slide over each other due to weak van der Waals forces. From this point to this point, the connection between the layers, it is weak van der Waals forces. So we are said it can slide over each other due to that weak van der Waals forces. For diamond, we talked of carbon atoms or the valency. These four valence electrons are all being used in bonding. For graphite, it only uses 3 electrons. Of the 4, it only uses 3 electrons to form the bond, and that 1 electron, we call it the localized electron, is the one responsible for electrical conductivity. So we can talk of graphite conducts heat and electricity due to that electron that is left during bonding, whereas diamond does not conduct electricity due to the fact that all the 4 valence electrons are used in bonding. Talk of melting and boiling point of graphite, they are high and obvious because of the covalent bond formed. But can you compare it with that of diamond? You will do that, learner. So it has covalent bonds between the atoms in its layers, and thus it has a high boiling point. We talked of it being slippery, and how can it be applied in a real life situation? Because we are talking of high melting point and its slippery nature. So it can be used as a lubricant in moving machines where a lot of heat is produced. And in an exam, you'll find a question asked why we use graphite as a lubricant than grease. We use the graphite as a lubricant than grease. Its advantage. So, and its high melting point also makes graphite be used in casting of metals. It has the localized electrons within its structure, and it can also be used as an electrode. So in the next lesson, I will introduce you to the chemical properties of carbon, because now we have talked about the allotropes of carbon which are graphite and diamond.